VisualFoil is an airfoil analysis program that allows you to test an airfoil using the computer, so you can tell which one will be the best shape to build a wing or a keel or a spoiler for a car. The program allows you to input an airfoil. The default is the NACA 0012, so we'll use that. And then we can see the airfoil right on the screen, and then we can actually test it. We can set the flow. Say here it's 100 meters per second. We can set it to miles per hour, and we can either use air or water. Then we do a fluid dynamics analysis to get the pressures on the airfoil. We could look at also the pressure in the flow field. We can look at streamlines. So as you can see, the program works just like a digital wind tunnel. The good thing about the VisualFoil is that it allows you to compare airfoil shapes. And why we want to do that is to see which one will give us the best performance right at the design point that we need. We can analyze this airfoil, for example, find the lift coefficient versus angle of attack. As you can see, VisualFoil will give you um, a nice lift coefficient curve at the setting of 3 million Reynolds number, and it does show uh, stall. Now, one airfoil by itself does not help you much unless you compare it to different shapes or different iterations on a particular shape. Here we are going to look at another airfoil, which we can bring up simply by clicking on the NACA 0012, and we could select, say, another 4-digit airfoil. Let's see the 4412, see how well that um, goes up against the 0012. And we look at the sail versus angle of attack again, and we see that for a given angle of attack, the NACA 4412 provides a higher lift, and we expect that because it's a cambered airfoil. Now let's just add another airfoil, and this time we want to look at the 5-digit shape, and it's the 23012, and again we look at the lift coefficient versus angle of attack, and we see that the 25012 has less lift. Now the lift and the stall characteristics, that's one design point, but what we really also want to look at is how the airfoils perform for a range of lift coefficients. And what we want to have happen is that the best airfoil will produce the less drag for the same lift. And as we can see, for a wide range of lift coefficients, the the NACA 4412 is doing the best job at producing lower drag. There are other features of VisualFoil that are useful for looking at airfoils. For example, we can set a flap um, on the airfoil, and we can see that we have another flow field set up. Um, Due to the flap, we have a different lift coefficient. Use VisualFoil if you want to look at different airfoils quickly and compare their performance, compare their transition points, their separation points, and actually come up with a good design for your wing and for a keel perhaps, or a car spoiler. This is Dr. Patrick Hanley at hanleyinnovations.com.